This is SAT Math Manual Section 19, which deals with scatterplots. Almost every single test is going to have a question or two that deals with scatterplots. Most students don't find these questions all that difficult. These questions do tend to overlap a lot with some of the items that we learned in linear equations, graphing linear functions, some of the stuff that we dealt with in quadratics, even some of the stuff that appeared in the exponential function section. So again, a lot of overlap with some other concepts, but scatterplots themselves obviously are a new concept in terms of this manual. So let's start with what is a scatterplot, and we might want to go ahead and highlight this here, because that's what a scatterplot is. A scatterplot is just a graph that relates two data sets or two variables. We plot the two data sets on an XY plane, combining the data sets as XY points. We will see what this means in one moment when we take a look at example 1. You should know that the vast majority of scatterplots that you encounter on the SAT will reveal a linear relationship, although occasionally you're going to see a scatterplot that reveals a quadratic relationship, maybe a trigonometric relationship, possibly even no relationship whatsoever. For instance, if you were to see a scatterplot that looks like this, where the points that are plotted don't appear to have any clear pattern. In other words, it almost just looks like we could almost create a flat line out of this, as if even though our x values are getting higher and higher, our y values don't seem to be increasing or decreasing. This would be an example of a scatterplot that might not reveal any relationship between the two data sets. Let's take a look at example 1 and see how this works. So example 1, of course, we've just got a basic scatterplot here. A quick glance, a quick visual inspection of the scatterplot should reveal this is probably a linear relationship. You can see that these points sort of follow a linear trend. In fact, we could almost draw in, we're going to talk about lines of best fit in a moment. We could also almost draw in a line of best fit there. So let's go ahead and do examples 1A and 1B. If you want to try these on your own, you can pause the video and then come back and join us. So we've got a scatterplot here showing the number of points earned on the final exam for 20 students. So we see points earned on the final exam on the y-axis going from 30 points to 100 points. That is being plotted versus the other variable, the other data set here is the hours studied for the exam. So these are the two variables, the two data sets that are being combined on this scatterplot. So each of these points, for instance, this point right here would represent a student, one of these 20 students, and you should be able to see there's 20 dots, 1, 2, 3, 4, and so on and so forth. There's 20 dots. So this student right here studied for 1 hour, right? That's the x coordinate. That's what's on the x-axis, and earned 35 points on the final. Woo, should have studied more. So that guy's 135. This guy here looks like he studied, maybe it's a girl, who knows, 3.5 hours and earned a 92. Way to go. Pretty good. Study hard, study long, get a good score. That's great. So again, that's what each of these points represent. We are combining the data set for hours studied with the data set for points earned. Hours studied, points earned. That's what each of these points represent. That's what a scatterplot is. We have to determine how many students studied no more than 2 hours, earned less than 60 points. No more than 2 hours. So I'm actually going to do this. I'm going to draw a vertical line. That vertical line represents the 2-hour mark. I'm going to draw a horizontal line at 60. So there's 60. And again, this question is saying no more than 2 hours. So that means we can't look at anything to the right, but we can look at the 3 points that are on the 2-hour line, because those students did not study for more than 2 hours. So we can look at points on that 2-hour line, but we also have to look at only those points that are below less than 60. So again, on the 2 hour or to the left. Okay, that's what no more than means. So nothing to the right, on the line or to the left. So, and then below 60. So that means we're looking at this student, this student, this student. I'm going to get rid of that red there just to make sure there's a point there. So all of these students. So 1, 2, 3, 4, 5, 6 students studied no more than 2 hours and earned less than 60 points. So the answer to this is 6 students. 6 students. Those are the students that, again, should have studied harder. What is the probability that a student scored more than 70? In this case, I'm going to circle this. More than 70, given that the student studied for at least 3 hours. Given that the student studied for at least 3 hours. So given that the student studied for at least 3 hours, again, what I'm going to do is I'm going to draw a vertical line at 3 hours. So at least 3. I'm going to actually get rid of this horizontal line here. If you want to erase that, you can. I know it's easier for me to do it than you. At least 3 hours, again, means 3 hours or more. So we're talking about on this line or to the right of it. That's what at least 3 hours means. And then more than 70 points means, in fact, if we want to do this the conventional way, maybe we even draw a dotted line there. We learned that back in linear inequalities, that we can draw a dotted line when the line itself is not part of the solution set. So what we are looking for is more than 70. So we're looking for above that line. At least 3 hours means on this vertical line or to the right. So we are looking at that. Again, let me get rid of that. Make sure there's a point there. There is that, and that. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 students there. And the quite tricky part of this question is realizing that you do not want to put the 8 out of the 20. This is very important. You're going to see this show up on the SAT. This language, given that, means that we are only to be choosing the students who scored more than 70 out of the students who studied at least 3 hours. In other words, this given that, what the given that language does is it restricts our denominator to this set. So if we were to select a student who scored more than 70 points out of only the students who studied for at least 3 hours, well, there's only, I'm going to do this in a different color, there's only one more student who studied at least 3 hours. And it's that student who I just circled in blue. So if we're looking at only the students who studied at least 3 hours, it's 9, right? These 8 plus this 1. And 8 of those students, 8 out of the 9 students, scored more than 70 points. So the probability that you were going to score more than 70 if you studied for at least 3 hours is 8 out of 9. That's a pretty good probability. It's almost 90%. So 8 out of 9. Again, very important not to make the mistake of putting a 20 in that denominator. The given that is telling you that you are not choosing from all 20 students. You are only choosing from the students who studied for at least 3 hours, and there are 9 of those students. That's one of the ways that scatterplots could be tested. Let's talk about some of the other ways that scatterplots can be tested. One of those ways, quite common way, is with a line of best fit. You heard me say at the beginning of this section that most of the relationships that we see developing on a scatterplot will be linear, and therefore a line of best fit will be a common part of a lot of these scatterplot questions. What is a line of best fit? I'm going to go ahead and highlight some stuff here. It is the line that best, let me get this out of the way, best expresses, approximates, or predicts the relationship. So again, if you want to glance back up at example 1, you can see that line that I drew. I'm going to do it again in green here so it's a little bit easier to see now that we're done this example. That line looks like it best represents, best approximates the relationship between the number of hours that you studied for the final exam and the points earned on the final exam. And you will notice that that line allows us to make a approximate prediction as to how many points somebody will earn given that they studied a certain amount of time. For instance, if I ask you how many points will some person earn if they study for, I don't know, let's say 2.75 hours, you can see that there's no students, there's no points at 2.75 hours. 2.75 hours would be about here. This is 2.5. There are a couple students at 2.5, but there's no students at 2.75 hours. But with the line of best fit, we can see that a student who studies for 2.75 hours is likely to get, or approximately will get, 70 points. Again, the observed or real world results might be different from that, but the line of best fit allows us to make something of a prediction as to how many points that student who studies 2.75 hours would earn. That's what the line of best fit allows us to do. Now, 2 criteria that a line of best fit must satisfy. Number 1, the line of best fit obviously should approximate the slope of the data set or the trend of the data set. And number 2, the line of best fit should roughly split the set in half. In other words, there should be roughly the same number of points above the line as below the line. On the top of the next page, we can see a couple of lines. This is our same data set that we were just dealing with hours studied versus points earned. Same 20 students. And we can see 2 lines that satisfy one of the criteria but not the other. So for instance, this first line here, that line approximates the trend or the slope of our points, but you can see that that line is below every single point. All 20 points are above that line. So this line does satisfy criteria 1. It gets the trend or the slope right. It does not, however, split that set of students, of 20 students, into roughly 10 students above the line and 10 students below. This line over here satisfies the second criteria, but not the first. You can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points below the line. Therefore, there are 10 points above. There were 20 total students. But clearly, this line does not reflect the trend or the pattern in the points. If we were to draw a line that sort of looked like the one I drew on the previous page, maybe something like that, that line should roughly do what we need it to do, although I think I probably put too many points below that line. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7. It's not too bad, actually, and there's a few points on the line. So the line that I just drew here in red would satisfy both criteria. We have the line approximating the trend, approximating the slope, as well as splitting the data set into roughly 2 equal halves. On questions where you do have to draw the line of best fit yourself, the helpful hint here, I'm going to highlight this, connecting the leftmost point to the rightmost point can make it fairly simple to find out where the line of best fit should be. So if you look at example 2, you can see that your leftmost, we'll read this question in a moment, the leftmost point is here, the rightmost point is here. Often you can get away with simply drawing a line through those points. In fact, I'm going to go ahead and do that right now. Oh, that was pretty good. You can draw a line between those 2 points and you will have drawn your line of best fit. That trick won't always work. You should always take into account what the question is giving you and the specifics of the question that you're on, but often College Board makes it fairly easy to draw a line through the leftmost and rightmost point in order to get your line of best fit. By the way, if you do need some help drawing a straight line, you can always use the edge of your bubble sheet. You could use a pencil. You could use, if you are on section 4, and almost all scatterplot questions will be on section 4, you can use the edge of your calculator or your calculator cover. So there are multiple ways to draw a nice straight line. If you can do it by hand, very good for you. So in example 2, let's go ahead and read through this. In this question, we're actually going to be asked to derive the equation of the line of best fit. So in the graph above, which of the following best models the relationship between H, the number of hours studied for the final, and P, the points earned on the final? So again, which of the following? So we need the best model. That's pretty much it. Best model means which of these linear equations would be the equation for the line of best fit. That's what this all means. So could we do this by picking 2 points and using those 2 points to find the equation of the line as we did when we talked about graphing linear equations? Yeah, we could do it that way. We could pick this point 0, 30. We could pick this point, let's say 4.5 comma 95, and we could use those 2 points to find out what our slope-intercept form of this equation is, and that'd be perfectly fine. I'm going to do this in a slightly more piecemeal way, where I simply look at the y-intercept. So right there, that point is 0 comma 30. So I know that b, the b in my y equals mx plus b, that b is the y-intercept, and I know that my y-intercept is 30, so I know I have to have a 30 in that b position. Answer choices A and D do not have a 30 in the y-intercept position. They have zeros in the y-intercept position, so answer choices A and D can go, and now I'm down to B and C. The only other parameter that I would need to maybe explore here would be the slope, 14.4 versus 1.4. I can see which one is more reasonable by simply finding the rise and the run. So the run from that leftmost point, I don't have to use the left and rightmost point, although they do look like the best options. But you know, I could pick any 2 points on the line. I could pick that point and maybe that point, but it does to me look like that left and rightmost point will be the easiest to use. So I'm going to go from 0, 30 up to that point there, and it appears that my run from 0 to what, about 4.5. So my run, let me do this, delta y over delta x, that's change in y over change in x, that is my slope. My run is going to be the denominator. So again, just to be clear, rise and run. Okay, so in the denominator, that's 4.5. Numerator, what am I going up to there? 95. I should probably write the coordinates of that point, 4.5 comma 95. So 95 minus 30 is 65, and I could do that in my calculator, so let me do it just to be sure. 95 minus 30 equals, yes, 65, and now I'm going to divide that 65 by 4.5 to get my slope. So I get 14.4. Wow, that came out nicely. That's exactly this slope. So even if you were a little bit off, even if you did 96 or 4.4, you should still get something that is closest to the slope in answer choice B, which means that answer choice B is our best equation for the line of best fit. I do want to make one point that College Board can be tricky with the y-intercept. They've done this once or twice, where I'm going to write this down over here. Just beware that if your x-axis does not come down to a 0 here, for instance, let's say you start at 10, maybe your y-axis is just 1, 2, 3, something like that. If your x-axis does not start at 0 and you've got a point, maybe you've got a point right here, you've got to note that is not your y-intercept, because this vertical line is not your y-axis. Your y-axis is at x equals 0. This point right here would be 10 comma 1.5. Remember that your y-intercept occurs when x is 0, so you have to be careful of assuming that that 1.5 is your y-intercept. In this question, indeed, our x-axis went to 0. Note that our y-axis does not actually go to 0. This point here is not the origin. This point is 0 comma 20. So you just got to make sure that you're paying attention to your axis scales and whether or not you're actually looking at the origin over here in the bottom left-hand corner of your graph. Just be careful. In example 3 at the bottom of the page, we have another line of best fit question. In this case, what we are being asked to do is well, let's read it and find out. So in example 3, scatterplot above shows the population of Sumatran orangutans in thousands in 2014 and several years after. Fine, so years since, so this is 0 years after. So remember, not that it really matters here, but remember that would be 2014, this would be 2015, 16, and so on and so forth. And several years after, according to the line of best fit to the nearest 100, what is the yearly decrease in number of orangutans from 2014 to 2018. So this language right here, yearly decrease, indicates that we need the rate of decrease. In other words, the number of orangutans that we decrease every year, which means we're dealing with a slope here. Slope is a rate of change. The question is asking us for a rate of change. So again, I'm probably just going to go ahead and use the leftmost and rightmost point. There's no rule saying I have to use the leftmost and rightmost point. Now, by the way, I'm using points on the line because the question is asking me to use the line of best fit, not the actual observed points here. So what am I going to do? I am going to, again, I'm going to do a rise over run sort of thing here. So my rise is there. My run, let's see if I can make a straight line here. Ooh, that got a little messy there. But I'm going to keep it. Anyway, my run is there, and now I should be able to see that over 4 years, right, from 0 to 4, that's my run. So again, let me do this. M equals, I'll do rise over run. Again, I could have done delta x, delta y. I'm just going to do rise over run this time. So my run, that's the easy one, that's 4. What's my rise? I'm going from, what is this point here? 4 comma 3.5. Does that make sense? This is 3, so halfway, yes, that would be 3.5. And then this point here is my y-intercept. That's 0 comma 7.5. Let me make sure. 7, but yes, that's correct. So my run is going to be 4. That's the 4 minus 0. And then my rise will be 3.5 minus 7.5, which is negative 4. So this equals 1. We do have to keep in mind that that negative 4 is actually negative 4,000. Why don't we write that? Negative 4,000 over here, which is negative 1,000, which means that my yearly decrease is 1,000 orangutans per year. That's what this number right here means. The population will decrease by 1,000 each year. Over 4 years, it will be 4,000. So the yearly decrease is 1,000. That is the yearly decrease. Whether or not you would need the negative, well, the question says what is the decrease? So the decrease is 1,000. You do not need the negative here. At the top of the next page, we've got to talk about nonlinear relationships when it comes to lines of best fit. So here we're not talking about lines of best fit anymore. We're talking about curves of best fit. If you glance at number 4, you can see what we're talking about. This almost looks like it is a quadratic curve of best fit. So you will occasionally see nonlinear best fitting going on a scatter plot. Let's actually take a look at example 4. You might want to try this on your own. This one might be a little tougher for some of you, but if you want to try it on your own, go ahead and then come back and join us. So in example 4, we have Nikhil calculating, I hope that's how you pronounce his name. I'm sorry, Nikhil, if it's not. Nikhil calculating his motorcycle's average fuel economy in miles per gallon. We can see that up here. Fuel economy, miles per gallon. Then we have speed, miles per hour. For various speeds. Okay, so that's that axis right there. Miles per hour on the scatter plot above. He recorded his data along with a best fit curve. So they'd come right out and tell us that this is a best fit curve. But again, we can see that on the graph. To model the data based on the model, which of the following is a, let's circle true statement. Wow, Nikhil has a lot of time on his hands to make such a nice chart here. But anyway, which of the following is a true statement? So can we predict here? I don't know that prediction is the best way to do this. We probably are going to just want to go to the answer choices and examine them one at a time. In other words, kind of backtrack this. But we could just look at this and say, all right, well, we do have a y-intercept of 0, 10. So that means that when he's not driving at all, his fuel economy is 10 miles per gallon. 10 miles per gallon. Let's say the vertex or the maximum seems to occur about there, right? What does that look like? Maybe 47.5 comma, I don't know, 68, 47.5 comma 68. So it seems his maximum MPG occurs at a speed of 47.5 miles per hour. So again, there is a little bit of legwork we could do before we look at the answers, but in terms of a question like this, probably best just to go one at a time through the answers and see which one actually is supported by the curve. So answer choice A, Nikhil's motorcycle maximum fuel economy is approximately 48 miles per gallon. So the maximum fuel economy is 48 miles per gallon. Well, 48 miles per gallon is here, right? Here's miles per gallon, 48 miles per gallon. That is not his maximum fuel economy. We said his maximum fuel economy was 68. Most likely what College Board is doing with answer choice A is they're trying to confuse students with that 48. You can see that the maximum point on the curve does occur at an X value of 48, but remember our x-axis is miles per hour, not miles per gallon. In answer choice B, we have Nikhil's motorcycle achieves its approximate maximum fuel economy at a speed. That one actually looks better. Remember, the answer choice B is actually what we said. We've got a speed of approximately 48 miles per hour. We said 47.5, and we are achieving its maximum fuel economy. Now, why do they have that word approximate there? It's because the quadratic here, this parabola, is an approximation. That's what a line of best fit is. It's just an approximation. So we are achieving our approximate maximum of, let's say, about 68 miles per gallon at a speed of 48 miles per hour. Cross off answer choice A. Answer choice B looks pretty darn good. Answer choice C, Nikhil's motorcycle's fuel economy increases by approximately 67 miles per hour as it accelerates from 0 to 50. Well, accelerating from 0 to 50 increases by 67 miles per gallon. Well, let's see. If we accelerate from 0 to 50, that means we're going from there to there. Do we increase by 67 miles per gallon? We go from 10 miles per gallon to about 68. 68 minus 10 is actually 58 miles per gallon. So if we were increasing our fuel economy, we would be increasing by 58 miles per gallon, not about 68. So that doesn't seem to be correct. Answer choice D says Nikhil's motorcycle has a fuel economy of approximately 67 miles per gallon regardless of speed. Well, that's clearly not true. Clearly the miles per gallon, the fuel economy, is varying when we change our speed. More specifically, as we increase our speed, the fuel economy is increasing until we reach a maximum point, and then it decreases, which means, again, the fuel economy does not stay the same regardless of speed. The answer here is B. Answer choice B does describe the vertex of this curve of best fit. Moving along to another question on which we actually are going to need to find the equation of the quadratic model. Students do tend to get quite intimidated. These are very rare questions. When they do show up, students do get slightly intimidated by them because it is a intimidating prospect to think that you would need to find the equation of a quadratic just given the curve itself. There are obviously ways to do that. Number one, it might be helpful, we do mention this here, to be familiar with the information that we went over in section 12, namely the important parts of a parabola and how to derive them from an equation. These questions can sometimes be done using that information. However, you also should know how to use your calculator effectively, namely the graph screen would be one way to do these questions. I'm going to go ahead and zoom out here so that we can see that curve up top. I know this is quite small. Let me see if I can zoom in a tiny bit more. There we go. That looks good. So what we're going to do first, we're going to do example 5 in a couple of different ways. One of them is we're just going to graph. So let's go into our calculator. I'll make the calculator bigger here. We've got a little bit more room. So we're going to go into y equals. We're going to clear out whatever we have in there. We are going to put in answer choice A, which is negative. Make sure you're using the negative and not the minus. 0.025, and then instead of s, I'm just going to use x, and we've got to square that, plus 2.4 plus 10. Okay, so that is answer choice A. Now, when I need to throw an x in there, sorry. So how can I do that? I can do second insert, you see that little blue insert, and hit an x, and everything will shift to the right. So now when I graph first thing I always want to do if my graph screen doesn't look right, if something looks funky, first thing I always want to do is do zoom standard, Z standard, which is number 6. Now, when I do that, you can see clearly what I'm looking at here looks nothing like what I'm looking at here. However, I am going to need to know how to adjust my window settings in my calculator to make sure that my graph on the calculator is reflecting what's going on the page. And we can see here that both our X and our Y axis go from 0 to 70, which means what I'm going to do is I'm going to go into window. I'm going to make my minimum X value 0, my maximum X value 70, and I'm going to do the same thing for my Y values, minimum 0, maximum 70. And now when I graph, I can see something that should look, actually, did I get that? I don't think I got my X value right there. Yeah, 70, my apologies. Now when I graph, I do get something that looks very, very similar to what I have in the graph that was given. So in a question like number 5, where they are asking me for the function that best expresses the fuel economy, okay, which means they're just asking me for the equation of this parabola, I can see that answer choice A is a pretty darn good candidate. Looks a lot like what I got up here. In answer choice B, I'm going to go ahead and switch up some stuff, but all I need to do is switch that sign on the 2.4. So I'm just going to go over that plus sign, and I'm going to hit minus, and then I'm going to graph again, because that's the only change I need to make, and clearly something's wrong. This graph over here would be, I don't know, something like that. Clearly that's not right, so answer choice B is gone. Answer choice C, what do I need to do? I need to get rid of the negative sign in front of the 0.025, so I'm just going to put my cursor over that negative and hit delete. And then these two signs, plus and plus, I need to make both of those positive. For some of you, again, if you're familiar with quadratics and parabolas and what parabolas would look like based on the equation, you would already know that answer choices C and D would be parabolas that would be the sort of normal way, the smiley face way, the open up way, because we don't have a negative in front of the first term there anymore. So if you know that, you could quickly get rid of C and D. I'm going to go ahead and graph this just to be sure. If we graph, indeed, we get something that does not look like what we have here. And again, I'm not going to go graphing D because I already know that it's going to have the same, answer choice D is going to have the same shape as answer choice C. So my answer here is A. Answer choice A is the only equation that when we graphed it on the calculator looked anything like what we had up here. Now there is another option that you have on questions like this in which you can plug in points. So for instance, let's say I look at that maximum point. Okay, let's say I can see my maximum point is about 48 comma 68, right? 48 comma 68. What I could do is I could go into my calculator and I could do negative 0.025 and then in parentheses 48 squared end parentheses. So what I'm doing is I'm throwing in 48 for my speed, for my S value, which means I would then do plus 2.4 parentheses 48 end parentheses plus 10. So again, everywhere I'm seeing an S in answer choice A, I'm just plugging in a 48. Now if I hit enter and I get something close to 68, I will know that answer choice A might be a good fit for this curve, and indeed when I hit enter I get 67.6. Now by comparison, if we were to look at something like answer choice D, so watch what I'll do here. I'm going to go up, I'm going to copy paste. If you don't know how to copy paste or you don't think your calculator can copy paste, you're just going to need to enter all of this again. I'm going to go back over that negative and I'm going to delete it because there's no negative in answer choice E. I'm going to go over the positive before the 2.4 and I'm going to change it to a negative. The plus 10 can stay the same. Now watch what happens when I hit enter here. I get negative 47.6. That's clearly not what I would need. So again, this is another way that you could do a question like example 5. You could pick points from the graph that's given, plug those points into the answer choice equations or functions, and see which of the answer choice equations or functions do what you need them to do, produce the results or the values that you need them to produce. At the top of the next page, we are going to finish up here by looking at a question that deals with an exponential curve of best fit. We already talked about linear, we talked about quadratic. Sometimes you will get a exponential curve of best fit. In such cases, again, the techniques that I just went over with you on the previous question will come in handy. Let's take a look at example 6. If you want to try example 6 on your own, that's perfectly fine. By the way, do note that we do cover exponential functions in a different section of the manual, section 15. Some of you might have already done that. If you have, you might be able to do this question on your own. And then come back and join me. So we've got a scatter plot that shows the world population P in billions. So here's the world population in billions, where X is the number of years since 1950. So again, this is 1950, 1955, 1960, so on and so forth. They want us to pick the best exponential model for this data. So again, I do want to remind you, we could just go in our calculator and graph these answer choices to see which answer choice yields a curve that looks like we have here. In fact, I'm going to do that for answer choice A so that you can see how we would adjust our window on a question like this. So what do we have in answer choice A? We have 2.519. Then we have a parentheses 1.0177, just making sure I am typing in exactly what is on the page. And then we are up to the X. So now if I graph this, I still have my window settings from the previous question. So what am I going to do? I'm going to hit window. My X minimum here will be 0. The maximum will be 50. So I'm going to hit enter and then 50, enter, enter. For Y, my Y values, I want my minimum to be 2, my maximum to be 6. So 2 over here. We've got 2 minimum, 6 maximum. And now when I graph, look at that. Looks pretty good. Looks pretty good. By comparison, answer choice, I'm not going to go through all these answers, but I will show you what one other answer would look like. Answer choice B would be 1.0177. I'm just going to overwrite this stuff. And then a parentheses 2.519 up to the X. And then I'm going to graph that. Clearly, that answer choice doesn't look anything like what I need. So again, just by graphing, it wouldn't take that long to just run through answer choices C and D to see what answer choices C and D produce. We could do it that way. But just by graphing, it looks like A is going to be my answer. I'm going to put a check next to that because I'm going to discuss a different way that we could do a question like this. Keep in mind, you could also do this by plugging in values. So you could, pick this point. Let's say this point is 50, 6.2. So you could take that 50, plug the 50 in for all of these X's and see which of these answers give you the 6.2 value that you would need. So again, that's another way. A third way is just to know about exponential functions, which again, if you've done section 16, you would know some of this stuff. First things first, we can see that we are getting 0, 2.5 as our y-intercept. So 0, 2.5. That means when 0 goes in for years since 1950, which is the X, 2.5 should come out. Well, remember, when 0 goes in for all of these X's, all of these terms, they all become 1s, which means you're just left with the values before the parentheses. Well, this guy and this guy wouldn't give us something around 2.5, right? 2.519 times 1 is 2.519. This would give us 1.0177, 1.0177. So answer choices B and D don't give us the right y-intercept. I am going to erase this real quick. And from there, we probably could just see that the multiplier, that's what these values in parentheses are called, the multipliers. The multiplier in answer choice A is greater than 1. The multiplier in answer choice C is less than 1. When the multiplier is greater than 1, you have an increasing exponential function that would have a graph that looks like this. When the multiplier is less than 1, you have a decreasing exponential function, which is a graph that would look like this. We clearly have something that looks more like didn't get a lot of those points in there. We clearly have something that looks like an increasing exponential function, which means we know that the multiplier would have to be greater than 1, which means we have confirmed that the answer should be A. So again, lots of different ways you could go about a question like example 6. You could graph, You could plug in some points from the graph given into the answer choices that are given. You could use what you know about exponential functions. These types of questions, exponential function curves of best fit, are not all that common, but now you know you have a few options. That is it for scatter plots. Again, make sure you know the information in this section. Make sure you review it often. Most scatterplot questions are not all that difficult if you do know this info.